Hello, welcome to this lesson in statistics. I'm Saj. We're going to start talking about another function related to F distribution. In fact, in the previous video, we paid attention about the F distribution, actually another form of the F distribution, which is the F probability density function. And in this lesson, I want to follow previous video and introduce another function, which is the FCDF function, which is short version of F cumulative density function. And also we will be exploring, learning how to calculate about this function in the different programming. First we will be focused on the definition. Let's look at our presentation. In fact, this form, function form is for MATLAB. I use it from MATLAB. We have a three variable d1 and d2 and x. X's are variables, and d1 and d2 is numerator and denominator. Actually, this form as formula is for FCDF, and the result of our function is like that for our variables. And the F distribution, cumulative distribution function, FCDF, gives the probability that a random. We reach this concept in our code and different programmings, and based on our previous educational method and our educational method, we have a simple example about our function. So let's look at our simple example. This slide is for our example. Actually, unlike what I did in the previous videos, we always introduced one example, but in contrast to what I did in this education about the cumulative density function, I decided to code for two different examples. First example is that we have a d1 equals to 4 and d2 equals to 10, but we have a one x. In fact, I want to calculate probability for smaller than 2.5, but in the another example I try to introduce the different concept about the cumulative density function, and this difference is related to x. We have a range of the x 0 to 5, but d1 and d2, our numerator and the denominator, is similar to first example of example. Actually, based on this explanation, we're moving to the next session, which is MATLAB workspace, to code our examples. Okay, this is MATLAB code place, and actually it is editor editor place for our code. And let's focus on our first example. So for this, CLC um, clear close all, and this is the numerator d1 equals to 4, and d2 denominator equals to 10, and x equals to 0.5. So I want to calculate FCDF probability for x, which is the 2.5. So I define p as a value for save our result and use the FCDF function x d1 and d2, and I want to show the result, this p and the p. So I run these codes. As you see, our result is 0.8. And another example is for a range of the x. So the d1, we change it. I define the range of the numbers between 0 to 5 with the 0 to 5. I use the line space function. Zero, 5, 300 number is true. Okay, and I run it. Yes, this is our number, and I want to I change this type of this line to comment, and I want to show in the plot. So use a figure plot x y actually for this is p, and line y is 2, x label actually change it. P, we can change it result CDF and title, or actually it's not necessary, and grade on, and run it again. As you see, our result, this is the result of the CDF for range of the number between 0 to 5. The probability for our range of the x. This is line. So in the next section, I want to do our first example with the Julia in the Jupyter workplace. First, I using package distribution package using distribution package, and D use F for denominator and the numerator, and the term x equals to 5, and in the next step p equals to CDF. Actually p equals to CDF, d and x. Next, print ln dot p and run. As you see, the result is 0.89. And for another example, we add plot and this line change, but we have a range of the x like other programming, MATLAB, Python. Actually I use 0 to 5 range. And delete this line and plot xp and equals to x equals CDF and grade true. Close bracket. So run these lines. We have an error here and must add comma and run again. So this is our result. This x and this is our plot, the range of x, and CDF, cumulative density function, for our range of the number between 0 to 5. This is Jupyter Workplace, and I want to go for our example. Let's focus on first example, and first import SciPy library, SciPy states import f, and define d1 as a numerator, and actually d1 equals 4 and d2 as a denominator actually 10, x equals 2.5, and another cell p equals f dot actually p equals to f dot CDF x d1 and the d2, and print p. Result is 0.89, and another example is like this, but we calculate the probability of a continuous random variable filling within the particular range of the values. It's mean we import firstly another library numpy as np, and actually we change it, import matplotlib dot pyplot as plt. We delete the cells and change it. We create a range of the numbers, np dot line space for between actually 0 to 5 200 numbers, and the p-value, and plot this result plt dot figure, and plt dot plot xp line width equals 2, and plt dot x label x, and plt dot y label CDF plt dot grade true, plt dot show. So run. We have a error here. We have an error here. It must change and delete e, and X. We have a ballot, but there are error. Change to capital, and our product is that cumulative density function in this section I want to code in R the Jupyter. First we have our first example, so D1 equals 4, D2 equals to 10, and X equals to 2.5, and for P I defined P as a variable to save our result of the probability cumulative probability density function for F actually. PF X D1 and D2 as a numerator and the denominator, and print P and run. As you see, the result is 0.89. And for another example, we change it. We have a range of the X, like what I did in the MATLAB, Python, and Julia. So